So have a look. Let's focus on the graph transformation stuff. Click them all the way closed and have a quick look. Let's just go through a few problems, that relate to this kind of thing, where we're choosing graphs, right? So what's our parent graph here for a problem like this? What are we starting with? X squared. Good. So we know we're starting with the graph, call it P of X for parent graph, equals X squared. Okay, so let's go ahead and graph that first of all. So where's the vertex of that parent graph?
Yeah.
At the origin. Good. And let's pick a few convenient points to guide our sketch here. So where do I go? What are some convenient points on X squared? 2, 4 would be 1. Over 2 and up 4. Over 1 and up 1. Maybe over 3 and up 9. Okay, so I got to go up a little bit here. So over 3 and up 9, so that's right there. Right, and if I connect all those smoothly, oh, that's pretty bad. Oops. What just happened here? I don't know. Let's try that again. Whoops. Well, I'm going to quit trying here pretty soon. Something like that, right? Not very good, but you get the idea. So we get the point over here at 1, 1. Here we get the point at 2, 4. And here we get the point at 3, 9. Okay, what are the values of A, H, and K for our transformation? So 6, okay. So we can see that A, first of all, A equals 6. What about H and K? Okay, so how are we going to, what's the order in which I've got to take my parent graph and change it? What do I do first? Dilate first, and then after I stretch it in this case, then I'll translate it so the vertex goes there, right? That's the easy part, okay? Let's do the dilation though. If A is equal to 6, think what A means. A is what we multiply the parent Y values by to get the dilated Y values, right? Okay, so instead of this thing being at, well, it's at 0, 0, isn't it? Because if I start with a Y value of 0, 0 times A, 6 times 0 is just 0. So we know that we're going to get, that value is going to stay at the same spot at 0, 0. But what about this point right here? Where is it going to get stretched to? Up to 6, isn't it? Because we're going to multiply A times 1 equals 6 times 1, which is 6. So this guy's got to get stretched all the way up to there, doesn't it? So now its coordinates are 1, 6. This guy right here, 4 times 6 equals 24. So that one's going to go way the heck up there to 24, right? The only one that we can probably see is this one, right? So this is going to be a really tall and skinny parabola, isn't it? It's going to look like that, right? And then eventually, where do I put that thing? 2, 4. So all I've got to do is put the vertex at over 2 up 4. So the vertex would just go over 2 up 4. So that's where our vertex would be. And what was our recipe? If that's the vertex, from the vertex, we just went over 1 to the right and up 6, right? So we would just go plus 1, 1, 2, 3, 4, 5, 6. Plus 6, so there's my other point. And we would just be looking for that graph. Right? The one that had, and what would those coordinates be? So this one we know is going to be at 2, 4. This one's going to be over 1 is going to make that a 3, and up 4, or up 6 from 4 is going to make that a 10. So those are the 2 points that are gonna anchor that graph, right? We know we're gonna pick the parabola that goes through those 2 points. Make sense? Okay? All right, what about something like this one? Okay, same kind of deal, right? We're starting with our parent graph, which is, we don't even need to graph it, we just need the points, really, don't we? So the points are gonna go through 0, 0, 1, 1, 2, 4, etc. What's the A gonna do this time?
Stretch.
Expand.
It's, okay, the 1/3 part's gonna make the y values smaller, so it's gonna vertically compress. What about the negative? It's gonna flip it, good. Okay, so if we take these, we take our normal y values, right? So if we take, like, our parent y values, we've got these points 0, 0, 1, 1, 2, 4, 3, 9. Let's see what those are gonna become when I dilate, right? So I'm gonna get 0, and then 0 times negative 1/3 is 0. Okay, so that one stays put. What about that one? 1, and then my y value times negative 1/3. What is that? What's 1 times negative 1/3? Okay, so that's not a very convenient one, right? We could use it, but it's not a very convenient one. How about this one? Over to 4 times, so 4 times negative 1/3 is just negative 4/3, isn't it? Right? And then this one works out okay, doesn't it? 9 times negative 1/3 is what? Negative 3, aha. So those are my convenient points, aren't they? Right? It's gonna give me the shape of this thing. Now, where should the vertex go? What are the values of h and k? Okay, good, so we can see h is 1, k is negative 3. And so we could put this thing over 1 and down, I wonder if I didn't, yeah, I guess it works. Over 1 and down 3, so there's my vertex. And then let's just use our recipe here. So we go over 1 and up 1, or I mean over 0 and up 0. So there's my vertex, right? And then from the vertex, this was the point we wanted to use right here. So we're going to go right by 3 and down by 3, right? So oh, that's pretty problem, that sounds like. Right, so that's the one we want, everybody agree?
Yes.
You can do that, right? Right. Really, all it amounts to is, is figuring out what's that gonna do to the shape of the parabola? How can I turn that into a vertex and another convenient point, right, to guide the parabola? And then we're just gonna dilate it so the vertex ends up at the right spot, okay? What about the opposite? What if we're given a function and we need to write, given a graph, we gotta write the function? To me, this is easier, right? So what the values of h and k are pretty obvious. What are those? So yeah, so -2, -3 are h and k. Easy, right? We just need to know a. So for a, we're going to get from our vertex to this point, right? From the vertex, we're going to the right by how much? By 3. And we're going up by 3. Now, on our parent graph, how much would we normally go up? If we go over by 3, we'd go up by 9. Okay, so we'd have to go up 3, 6, 9, up to there, right? So this has clearly been squashed, hasn't it? Because this point that would have started there has been squeezed down to there, hasn't it? Right? So if we want to come up with the value of a couple ways we can do it. We know that our original y coordinate, So 9 times A should equal 3. All right, because that's what we do. We multiply A by our parent Y value to find the dilated Y value. So what do we end up getting? If I divide both sides by 9, what's that work out to be? Right, so 3/9 would just be 1/3, right? Or the other way we could always think about it is A equals the dilated divided by the parent, right? The dilated is 3, parent is 9. 3/9 gives me 1/3, right? Either way, I know A, I know H and K, and so my answer is just, I get 1/3 times X minus -2, all right, so X plus 2 squared minus 3, right, if I plug all that stuff in. You with me? Okay. So I'm gonna skip all this. This is all stuff, I mean, we've gone through this before. You can go back and look at notes or look at, you can look through the stuff we've already done to find this. I mean, maybe I'll look at one quick one. If we solve this when f of x, which is y, right, when y equals 1, there's the horizontal line, y equals 1, isn't it? So let's use the graph. What's the solution? X equals what? 3. Well, just 3, right? The point of intersection is 3, 1, but we just want the x value. So x is 3, right? What about now? What if we tried instead, let's say, instead we're going to change this to f of x equals -3. So now what are the solutions? So there would be my points of intersection, right there, and right there. So what are those x values? -9, right? Okay, what if instead we did f of x equals +4? What are the solutions? No real solutions, right? No intersection, okay? Okay, that stuff you can do. I mean, that's just, we've been through that a bunch. That's just using Desmos, right? To evaluate and find average rates of change. Here's the part I want to focus on. Okay. So what about this? So we want to do g of x in terms of f of x. So we're starting off with f of x. Now let's just take this one step at a time. Did we do this where we kind of color-coded the steps? We did do something like this? Okay, so let's just remind me how this works. So if the first step is to vertically stretch by a factor of 9, what's that going to do? Okay, 9 outside, isn't it, right? Okay, and then if we're going to reflect horizontally, what's that do? Right, but what do I have to change to make it do that? Negative goes where? No, in front of the x if I'm reflecting horizontally, right? So next step would be g of x equals 9 times f of -x. And that's it, right, those two steps. Okay, how about this one? So we're starting with, this time we get x squared, it's something specific. Was the last one specific, or was it? No, that one, they didn't tell us what the function was. We were just doing it in terms of f of x. This time we get an x squared, right? So the first step is g of x equals x squared, right? So let's do these in order. So if I do vertically stretch by a factor of 5, what's that do? I'm going to multiply outside by 5, right? Okay, now we're going to do translate 5 units up. What's that? So now we get our plus 5. And then finally, we're gonna get our translate 7 units right. What's that do? Okay, that's where we're gonna subtract h from x. In other words, we're gonna replace the x with an x minus 7, right? So this part right here just becomes x minus 7. Okay, and then squared, right? Does that make sense? Okay? Okay. So same thing, we're starting with x squared. Vertically stretch by a factor of 3, what's that? And vertically reflect, what's that do? Yeah, but how do I do it? Okay, I'm gonna multiply outside, right? So that means we're gonna multiply outside by a negative, so now we have negative 3x squared. Translate 2 units down, so I'm just gonna subtract 2, right? And 1 unit to the left, so 1 unit to the left, what's that gonna do? But where's that go? Inside, right? So that's gonna be inside the function, so I'm just replacing the x with an x plus 1, right? So the last step would be negative 3 times x plus 1 squared minus 2. Okay? Make sense? Okay, so let's work. The rest of it, I could go through it all, but I don't think I think most of you don't need these things. So if you do, you can get some questions answered individually. Then we'll leave you on your own on the other side. That's the main part that's probably the most sophisticated from what we just did. Okay.